Next question is, given a string, find the first non-repeating character in it and return its index. If it doesn't exist, return -1. So some assumptions and clarifications. The string may contain lowercase characters or possibly all ASCII or Unicode characters. We need to clarify the domain in the interview. Then first non-repeating means the earliest position in the string whose character appears exactly once in the entire string. If no such character exists, that is every character repeats at least once, we return -1. We want to do this efficiently, ideally O of n time, using manageable extra space. So for example, input given is s, the string is hello world, output is index 0, that is the character h, because it is non-repeating, that is there are no duplicate entries for h, there are no duplicate h is present, and this is the first index where it is non-repeating. Similarly, next example concussion, you have index 4, that is u. Next, moving on, we have two nested loops. Idea: for each character, position I in the string, check if that character repeats somewhere else. Scan the rest of the string. The first one that never repeats is the answer. This is the pseudocode. For I in range 0 to length of s minus 1, that is n minus 1, is unique is true. For j is equal to 0 to n minus 1, if j not equal to I and s of j is equal to s of I, is unique is false, we break. And if it's unique, it remains, we return the index I or return -1. This takes O of n square in worst case. For each I, you have to scan the whole string. So the space complexity, time complexity is O of n square and space complexity is O of 1. This is simple but too slow for large strings. Now moving on, use index of last index of trick. Now this is Java specific. String.index of char finds the first occurrence and string.last index of char finds the last occurrence. If for a character C we have this equal index of C equal to last index of C, then C occurs exactly once. So one approach is for I 0 to n, if index of S of I is equal to last index of S of I, return I. This finds basically the first occurrence and finds the last occurrence, right? This hides scanning in the index of last index of calls, which themselves do linear scans internally, making this approach effectively O of n square. Some developers mistakenly think this is O of n, but it is not in general. Now, the efficient or the optimal approach, moving on to that. So we want something like O of n time and using extra space proportional to character domain. For example, constant if the domain is bounded. So we have to see for a first pass, count the frequencies of each character or record the occurrences. Then second pass, scan from the front, find the first character whose count is exactly 1. Return its index. If none found, return -1. So we follow the two pass or frequency counting. Approaches use a hash table or map or an index, any index structure, where we can count the mapping of each character to the integer that is the count. First, iterate over the string, incrementing count of character. Then iterate again from I0 to n. For each s of I, if count s of I is equal to 1, return I. If the loop completes, return -1. Now complexity time is it takes O of n. Space O of k, where k is the size of the character domain. For example, 26 for lowercase characters or 256. Now one pass with indexing, first occurrence tracking plus frequency. So you can combine frequency tracking with first occurrence index tracking in one pass. So maintain a map or array frequency of character is equal to count of occurrences. Also maintain a map array first index char, index of the first time character is seen if not previously seen, right? So we can have these approaches, or we can have an ordered structure or queue for streaming scenario. If characters come as a stream, that is you don't want to store all input or you want to be able to query current first non-repeating at each step, you can use a hybrid of frequency plus queue. So maintain count of char, maintain a queue or linked list of candidate characters in the order they appeared. For each incoming character C, increase the count C. If it's the first time, count becomes 1, push C into the queue. While queue is not empty and count of queue.front is greater than 1, pop from queue since they are no longer candidates. That is, they don't have non-repeating characters because the frequency has increased more than 1. And the front of queue, if any, is the current first non-repeating character. At the end or at each point, the queue's front gives the answer. Right. Now moving on. So these are the complexity summaries. You can see. You can have a look. I'll attach this in the description, the link of this chat. Now moving on. This is the sample code. So this is the Python 2 pass frequency method. So we have frequency map first. So first pass we count the frequencies for C and S. Frequency of C is frequency.get C, 0 plus 1. And second pass, first find the first non-repeating character, that is first character which has frequency equal to 1 in the whole string. So for I, C in enumerate of S, if frequency of C is equal to 1, return I, otherwise return -1. Now one pass with first index plus frequency. Frequency and first index we have two maps. So for I, C in frequency in enumerates S, we check again the same thing. We first initialize, and then if C not in first index, we set the first index of the character at that particular index as I, and then finally get the answer. Now C++, we use an unordered map char of int of type char, int frequency of C++ for each character in string. And finally for I0 till the whole length, if frequency of S of I is equal to 1, we return I, otherwise we return -1.